Hey everyone, welcome to Security by Star, where we simplify cybersecurity one layer at a time. In this video, we're breaking down one of the most powerful tools in modern web defense, the Web Application Firewall, or WAF. By the end of this video, you will understand what a WAF does, how it protects your site, and why it's an absolute must-have for every organization that lives online. Stick around because I will also show you real-world examples of cyber attacks that a WAF can stop, so you will see exactly how it protects you. Let's jump right in. Every single second, web apps across the world are under attack. We're talking about bots scraping data, hackers injecting malicious code, or bad actors trying to brute force their way in to login portals. Without protection, your site can leak sensitive data, crash, or even hijack to attack other websites. Yep, that means your websites could be intentionally become part of someone else's cybercrime. Take bots for example. Some are good, like Google crawlers indexing your sites. But others, not so friendly. They can mimic real users, bypass basic security checks, and quietly steal things like customer logins or credit card numbers, all while you think everything is fine. That's where a web application firewall comes in. Think of it like the digital security guard standing between the internet and your web app, constantly checking IDs and keeping the bad guys out. So what exactly does a WAF do? A WAF monitors and filters traffic between your web app and the outside world. It inspects every single request, every click, first submission, and API call, looking for patterns that match known attacks. For instance, SQL injection, cross-site scripting, and file inclusion are some of the most common ways hackers try to exploit apps. You can picture it like a digital bouncer at the club entrance. Real guests get in smoothly. But if someone shows up wearing a Hacker 101 t-shirt, trying to sneak malware in their packet, they are getting bounced out immediately. Even better, modern WAFs can learn. They use behavior analysis and machine learning to detect new attacks that haven't been documented yet. So, while hackers are busy evolving their tricks, your WAF is evolving too, automatically. Let's go behind the scenes for a second. When a user visits your site, the request first passes through the WAF. The WAF checks it, using a mix of rules, signatures, and behavioral patterns. Think of these rules like an airport security scanner. Each layer checks for something specific. Maybe strange input, unexpected file uploads, or odd user behaviors. Some WAFs even use threat intelligence feeds, meaning they are constantly updated with the latest global attack data. There are also two modes: detection mode, which only monitors and alerts, prevention mode, which blocks suspicious traffic in real time. Many organizations start in detection mode to test what's being flagged, then switch to full prevention once they trust the configuration. And depending on how it's deployed, a WAF can live in the cloud or directly on your servers. Cloud WAFs like AWS WAF, Cloudflare, or Akamai are fast to set up and scale automatically. On-prem WAFs, on the other hand, gives you a more control and customization, but require ongoing maintenance and updates. Some even integrate directly with bot protection, DDoS mitigation, and zero trust system, working as part of a complete perimeter defense. So, whether you're hosting one website or thousands, a WAF is like having a 24/7 virtual security analyst monitoring every request, Now, not all WAFs are created equal. Let's break down the three main types. Network-based WAF. Installed at the network edge. They are super fast and reduce latency, but can be expensive and complex to manage. Host-based WAF. Run directly on the web service itself. They are customizable, but use up server resource and require more maintenance. Cloud-based WAF. Offered by providers like AWS, Cloudflare, or Azure. These are easy to deploy, scale automatically, and are perfect for protecting multiple sites. Each type has trade-offs. It's all about your use case. A small startup with a few apps might go with a managed cloud WAF. A global enterprise might combine all 3-4 layers defense, like having multiple shields that back each other up. So why does a WAF really matters? In short, because attacks are getting smarter, faster, and cheaper to launch. Hackers don't need to be genius anymore. They can literally rent attack tools online for a few bucks. Having a WAF isn't just about blocking threats, it's about visibility. You can see who's hitting your site, what kind of attacks they are trying, and how often. For example, a WAF dashboard might show 20,000 login attempts from a country in an hour. That's a clearly sign of a brute force botnet attack. If you're running an e-commerce or healthcare platform that handles personal data, that visibility could mean the difference between catching an attack early or becoming tomorrow's headline. A retail company noticed sudden spikes in traffic late at night. Their WAF automatically flagged and blocked thousands of fake logins, protecting hundreds of customers' accounts. No downtime, no breach, just automated defense working quietly in the background. So there you have it, the Web Application Firewall, your silent, tireless bodyguard for the digital world. It matches every request, filters out threats, and gives you control over who gets to interact with your apps. If you found this video helpful, hit the like button, it really helps the channel. If you are new here, subscribe to Security by Star for more quick, simple, and practical cybersecurity breakdown. Next video, we will dive into how WAFs work together with bot management and DDoS protection, so you can understand the full cyber perimeter. Thanks for watching, stay secure, and I will see you in the next one.